All right, we're going to go over the Unit 7 practice test and just kind of see how you would be expected to do all these problems and kind of see the skills you needed for the Unit 7 test. So this first page is all about verifying the solution to a differential equation. So basically I'm going to give you a differential equation, which means there's that derivative in the equation. And I'm also going to give you the function that's a potential solution. So we determine if this is a solution. So remember, it's a solution if when I plug everything in, this equal sign makes sense. So let's zoom in to the specific problem. All right, so if we're going to plug this in, well, we first need to be able to plug in y prime. So we need to figure out the derivative of this function. So y prime, take the derivative of e to the negative 3x. The derivative of the exponential gives you back the same thing. And because I have this negative 3x in the exponent, I have to do the chain rule, so I have to multiply by another negative 3. I'm going to put it at the front. It's at the back of the start. And then derivative of 2x is 2, derivative of 3 is 0. All right, so that's our y prime. I'm going to plug this in here. So now I'll have y prime plus 3y. Well, y prime is this thing we just found. Plus 3 times y is this original y that's given to us. And now we can distribute this 3 in. And then two things cancel. We have this minus 3 and this positive 3 of e to the negative 3x. Those cancel. I can combine these two like terms. I have the 6x here, and this 2 and this 9 make 11. All right, so this left-hand side equals eventually the right-hand side. So that means this is a solution. So just write something simple like y is a solution. All right, for the next problem, same thing. We're given a y, we're given a differential equation, we know if it's a solution, so we have to plug everything in here. Really, we just need y prime. So y prime, derivative of 4 is 0, the natural log of x is 1 over x. So I take the left-hand side, x, y prime minus 2. Y prime is equal to 1 over x. X times 1 over x, the x's cancel, and I get negative 1. So the left-hand side here is equal to negative 1, which is not 0. So this doesn't work. So y is not a solution. All right, so for this skill, you'll be given the y. Just make sure you can take the derivative. You might even need the second derivative if it's in the equation. Plug it in and just make sure the equal sign makes sense. So we saw in the first example, we got exactly what we wanted. The second example, we didn't get what we wanted. It's not a solution. And our next skill is all about slope fields. So remember, slope fields are just representing these like small tangent lines that, because dy dx represents the derivative, which is the slope of the tangent line. All right, so these are all just tangent lines. So when I look at creating my own slope field, for every single one of these black dots, I'm going to put in that x and y value into this expression, and then just draw a little line with that slope. There's a couple that's going to save me some time. If I put in x equals 0, I'm going to get 0 times y minus 1, which is 0. So whenever x is 0, I'm going to get 0, which is a flat, let's do it in a different color, flat line. And so whenever x, oh my goodness, you cannot draw a flat line. There we go. All right, so whenever x is 0, which is all these points on the y-axis, my slope is 0. The other time is if y is 1. I also get 0, so every single time that y is 1, I can get 0. So these are just saving me rather than plugging in every single point. All right, so those ones I can put on are all going to be flat, and then every other point I just kind of have to plug in the points and see what I get. So if I plug in negative 1, 2, it's going to be negative 1 times 1 is negative 1. Remember, if it's exactly 1, it's like a 45 slope. If it's negative 1, it's exactly a negative slope. Negative 2, 2. It's going to be negative 2 times 1 is negative 2, so it's going to be steeper downward than that one. 1, 2 is going to be 1 times 1 is 1. 2, 2 is going to be 2 times 1 is 2, so it's steeper than 1. negative 1, 0 is going to be negative 1 times negative 1 is positive 1. Negative 2, 0 is negative 2 times negative 1 is positive 2. It's steeper than 1. 1, 0, 1 times negative 1 is negative 1. 2 times negative 1. I have negative 2, negative 1, so it's negative 2 times negative 2 is positive 4, so it's even steeper than my 2 one here. Negative 1 is 2. Again, I'm just plugging it in here and simplifying. 1, negative 1 is 1 times negative 2 is negative 2. I'm guessing this one's going to be negative 4. All right, so you can see all the lines. Again, when I'm looking at this, I want to make sure that you have the flat places. All right, those are the ones that, like, there's no getting around the fact that it has to be exactly flat. I don't even think that's exactly flat, but all right, exactly flat where it should be 0. If it should be 1, it should basically be like this 45-degree angle going up. It's a negative 1. And then for the numbers that are bigger than 1, all right, just make sure it's steeper than that. All right, so any of these ones would really be fine. They're all steeper. They're not exactly 2 or exactly 4, but that's fine. And if it were to be smaller than 1, we didn't get any in this one, but they would just be less steep. So that's like 1/2 and 1/3. That should be less steep than 1. And the next two questions are much quicker. All right, we're given a slope field that represents a differential equation. We're given an initial condition. So what we're going to do is put this initial condition on our graph. Negative 1, 1. It's about there. And then we want to sketch the solution curve. So remember, that just means we're going to follow the slope field. So going to the right, this line's pointing me down. This line's down, but more to the right. And then this like flat piece is going to level off. And then going left, I'm kind of going against these ones like that. All right, so this would be my solution curve if I had negative 1, 1 as an initial value. And it all depends on what the initial value is. So just pretend like it gave you negative 2, negative 1. Then you would put that dot there. And you would follow these curves like that. If it gave you 1, negative 2, you would follow these curves up like that. All right, so it just depends on what your initial condition is. You put that dot and then just follow your lines. And same thing for this one. We have 0, 1 is here. Going to the right, this line's pointing me down to this flat section. Going against it, it's pointing me left to that flat section. And again, different initial values would give you different things. So if I had an initial value here, my graph would look something like that. If I had initial value here, my graph would look something like that. All right, so depending on the initial value, it can be a completely different final solution. Just make sure you're following those little lines and creating your graph. All right, our next skill is solving separable equations. This is like the big thing of this unit. So we given a differential equation, you want to find the answers. All right, and if you look here, this is one of the only problem or skills that's worth more than 10 points, right, because there's a lot of stuff in this one skill. All right, so this one's worth a lot of points. All right, so we've got to make sure we know how to do it correctly. So when we're solving a separable equation, zoom in. All right, the first thing I'm going to do is separate the variables. So I already have dy on the top over here, so I want to get this y over to the left. And then this x, we're just going to multiply to get over there. All right, so first thing is separate the variables. So I'm going to multiply both sides by 2y and multiply both sides by dx. All right, so those cancel, and I get 2y dy equals 3x squared dx. So I separated my variables. All the y's are on the left, all the x's are on the right. Now I can integrate both sides. On the left-hand side, the integral of 2y is y squared. Add 1 to the exponent, divide by 2. On the right-hand side, add 1 to the exponent. Dividing by 3 cancels out with that 3, plus c. And then, now that I took my antiderivatives, now I want to solve for y. Right now it's just y squared, so I take the square root of both sides. And I get y equals plus or minus the square root of x cubed plus c. If we had to figure out c and had an initial value, we could determine this plus or minus, but right now we don't really know if the plus or minus is right, so we'll just leave them both. All right, next question, same idea. It's going to be a little bit different because here I'm going to have to multiply by 1 over y to cancel these y's out. But I'm always going to multiply by dx because it'll cancel those out. All right, so now the equation becomes 1 over y dy equals 1 over x squared dx. All right, once I separate, I integrate. And these two look very similar. 1 over y looks really similar to 1 over x squared, but you actually do these antiderivatives in two different ways. 1 over y turns into the natural log of y. 1 over x squared, well, 1 over x squared is x to the negative 2. So I'm going to add 1 to that exponent and divide by the new exponent, and then do plus c. And you can leave it like this. I'm going to rewrite it without the negative exponent. All right, so that's our antiderivatives, and now we want to solve for y. All right, we've seen this a lot, is to get rid of this natural log, we raise both sides to the e. E and the natural log cancel, so we just get y. On the right-hand side, we get all of this in the exponent of the. And I'm fine if you leave it like this. A lot of times when you have the c in the exponent, you can do some manipulation and actually write it like this. All right, but I'm fine either way with you leaving either one of these. All right, we're still in the same skill, and this is one of the reasons that it's worth more points, because there's more types of questions. All right, but this is the same thing, except for now we're finding a particular solution. That just means we have an initial value, and that just means we can find c. All right, we can find the c value. So we're still going to do the same first steps. We're going to separate our variables. All right, doing the same thing, getting those y's to the left, x's on the right. So we're going to 1 over y squared dy equals 2x plus 1 plus c. Oh no, not 2x plus 1 plus c, just 2x plus 1 dx. We haven't done the integration yet, so there's no plus c yet. Now I integrate. We just saw the integral of 1 over something squared here. It's negative 1 over x. This 1 over y squared is going to be negative 1 over y. The antiderivative of 2x becomes x squared plus x plus c. And now here's where the particular solution is different. Now I plug in my initial value, so I'm plugging in 1 for y and 0 for x. I get negative 1 equals c. All right, so now my equation is negative 1 over y equals x squared plus x minus 1. And now I want to solve for y. In my opinion, the easiest way to solve for y is, well, first, I can't solve for when it's in the bottom of a denominator, so I'm just going to multiply both sides by y to get it out of the denominator. So that cancels there. And then I can get the y all by itself on the right by just dividing both sides by this x squared plus x minus 1. And I'm going to get y all by itself. I'm going to write it on the left now just so it's like y equals, but this y is all by itself, and on the other side we have negative 1 over x squared plus x minus 1. Alright, so this is basically the same thing we just did in the first page of the skill. The only difference is this kind of middle section here. Alright, we have to figure out c, but other than that, it's pretty much the same thing. You just have a value instead of a c hanging around. All right, and this last one is similar to the one we just did. We're finding a particular solution to this differential equation. All right, there's only one difference with this last one is you don't actually have to do all of this work because this is a special type of differential equation. Whenever you have just a number times our variable, this is an exponential model. And whenever you have an exponential model, my solution for y is ce to the kt. And in our equation, k is the number that was next to our variable here, so that's going to be e to the 5t. And c is your initial value where you start out. Well, I start out at 200, so it's going to be 200 in front. And that's the whole problem if you know the kind of shortcut that this is an exponential model. If not, you would have to separate your variables, take antiderivatives, solve for c, and then solve for y. You'd end up getting this anyways. But you can save a lot of steps if you recognize it's just a number times my variable up here. It's an exponential model. All right, our next skill is just taking derivatives with exponentials and logs, making sure we know these new derivatives that we know. You need them a little bit for the other skills, but this is just all at once, making sure you know these. All right, so first one, the derivative of an exponential gives you back the same thing. And then because there's an extra term in the exponent, I have to do the chain rule, which is its derivative is 8. All right, so that's just the chain rule. Same thing with this one. This one's going to be a chain rule 1. The derivative of a natural log is 1 over whatever's on the inside. And then because there's something else on the inside, I have to multiply by its derivative to do the chain rule. That's 5. And if you left it like this, I'm not going to take off points for the test, but the 5's cancel, and you get 1 over x. All right, so these are our basic exponential and log derivatives, just remembering that if there's an extra number or anything in the parentheses or the exponent, you have to do the chain rule. All right, for h of x, we have x times e to the x. So for this one, we have to do the product rule. All right, so we're going to keep x the same. We're going to multiply that by the derivative of e to the x, but it's going to look a little weird because the derivative of e to the x is e to the x. And then we keep e to the x the same, and multiply by the derivative of x, which is 1. So if I kind of write it a little bit nicer, x e to the x plus e to the x. All right, so that's our derivative. And again, we kind of talked about this when we saw a problem like this before. Chances are this was a multiple choice question. The actual answer would look like this because they would factor that e to the x out. I'm not expecting you to do that for this because you don't have like the multiple choices to look at. So this answer here would be good. All right, for p of x, we have the chain rule. We can see these parentheses. The cosine is inside the log. All right, so we always do the log first. All right, so the derivative of the log part is 1 over whatever on the inside. And then we're going to multiply by the derivative of the thing on the inside. The derivative of cosine is negative sine. And again, I'd be fine if you left it like this, but it turns out the negative sign is going to stay, and then sine divided by cosine is tangent. So that'd be the simplest way you could write it, but I'd be fine if you just left it in the unsimplified form for this test. All right, s of x, again, we have these parentheses with something on the inside, so we're going to have to do the chain rule. So we start with the outside. Derivative of tangent is secant squared. Remember, whatever's on the inside of the parentheses stays the same, so e to the 4x is still going to be in here. All right, then we multiply this by the derivative of the inside. The derivative of the e part gives us back the same thing. All right, then within this, we had this 4. We had to do another chain rule and get a 4. So we did tangent turns into secant squared. The exponential turns into itself. That 4x turns into 4. So we're just slowly working our way in using the chain rule. And this last problem, we have division, so we have to do the quotient rule. So t prime of x. All right, so low d high minus high d low over low, the bottom squared. Again, for the test, I'm fine if you leave it like that. You could write it like this. X cubed and 1 over x would cancel out to give me x squared minus 3x squared natural log of x over x to the 6th. Right, so that's one way you can simplify it. All these terms have an x squared in it, so I could actually cancel that out. And not something I'm expecting you to do on the test, but I just want to show how you could simplify it a bit more to get that expression. All right, so this is just taking our derivatives of these, our final two function types, exponentials and logs. Our logs give you 1 over whatever on the inside. Exponentials give you back the same thing. All right, this skill, same thing, but in reverse. So now we're doing our antiderivatives. So and there's less of these just because they take a little bit longer. All right, but this antiderivative, if exponentials give you the same thing when you take the derivative, they're also going to give you the same thing when you take the antiderivative. But instead of multiplying by this 4 because of the chain rule, we're trying to reverse the chain rule, so we're going to divide by this 4. And that's going to be our final answer. So we're just kind of undoing the chain rule with that 4. I would generally write it like this. It's the same thing, but I like to put the kind of fraction out in the front. Either one of these is fine. All right, for this one, 1 over something is going to go backwards to the natural log. So this one's going to be the natural log of the absolute value of x minus 3. Again, we talked about why the absolute value is important because you can only plug in positive numbers into a log. But just like we saw in this problem, because we have this 4x, normally we'd multiply this 4 with a chain rule, but we're reversing it. So normally we'd multiply by this 8, but we're going to divide by it instead. All right, so this would be the right final answer. So whenever there's just a number next to the x, you have to divide by it when you're doing your antiderivative. This one to the left here, you might be thinking of like trying to reverse the product rule. Remember, when we're doing integration and antiderivatives, we have to make the problems really simple before we take the antiderivative because antiderivatives are much harder. So we can't undo the product rule, even though we had this multiplication here. So really our only option is to do u substitutions. We need to pick a u. And your u is always going to be something that you see its derivative is in the problem. And x squared, its derivative is 2x. So I know its kind of derivative is somewhere in the problem. So that's going to be my u. du equals 2x dx. du over 2x equals dx. All right, so now my problem becomes x e to the u du over 2x. All right, and the x's cancel just like they should, so I only have u's. And there's 2 still on the bottom, so I have 1/2 e to the u du. And its antiderivative, well, the 1/2 just stays because it's a constant multiple. And the antiderivative of an exponential is itself. And so that's pretty simple. And then I just have to plug back in my u. All right, and that's my final answer. All right, so it's just making sure you still know u substitution and recognizing that you can make u the exponent of your exponential in order to get a more simple antiderivative. All right, this one, same thing. If you're kind of confused, all right, we can't separate this into separate fractions because of that minus sign on the bottom. So like, what else can we do? We got to do u substitution. What should we make u? All right, well, we're looking for the bigger thing. It wouldn't make sense to make u 3x squared minus 1 because that would differentiate into something smaller than this. So we're going to make u the bigger thing, x cubed minus x. Du is going to be 3x squared minus 1 dx. Divide it. Du over 3x squared minus 1 equals dx. We call this bottom u, and then dx is du over 3x squared minus 1. And this one's real nice because the whole thing cancels, and we just get our simplified form, which is 1 over u du. We know its antiderivative, the 1 over u just turns into the natural log. And then we finally replace what u was, x cubed minus x. So these last two are really similar to the top two, just with the u substitution thrown in. You're just trying to convert it to a simple exponential or a simple log antiderivative. And so those are some basic examples of doing antiderivatives when they get an exponential or a log as your answer. All right, and our final skill is about finding volumes with cross sections. All right, so remember the basic idea is you think about what the area of one of the cross sections is, and then you just integrate that over the whole space. All right, so if we have R is the region under the square root of 4 minus x squared above the x-axis. All right, the square root of 4 minus x squared is a semicircle with a radius, the square root of 4, so 2. So this is negative 2, and this is positive 2. So this is one of the basic shapes that comes up a lot that students aren't super confident with. So knowing the formula for a semicircle can help a lot and save you some time. All right, so there's a solid, and its base, cross sections is a square. All right, so for each one of these, I'm going to do a square kind of coming out of that region. All right, what is the volume of the solid? All right, well, the volume is the integral of the area. All right, so for our example, it's going to be the integral from negative 2 to 2. And the area, well, a side is from this region is the square root of 4 minus x squared. But then it's a square, so you multiply the length times the height, and they're the same, so you're just squaring this. And we can simplify first. All right, the square root cancels. And now I can do antiderivatives first. So I take the antiderivative of this. All right, then I'm going to plug in 2 first. I'm going to subtract when I plug in negative 2. And then just try to simplify. So this is 8 minus 8/3 minus negative 8 plus 8/3, which is, change those to positive, that's to negative 16 minus 16 over 3. And let's just leave it like that. Because if this was a free response question on the calc exam, you don't have to simplify once you have like a numerical answer. So actually you could leave your answer like this, the first green part, and that would technically be right. But also, if it was a multiple choice, generally we'll leave the fractions and the numbers separately. So chances are, on the AP exam, 9 times out of 10, we did more steps than we would need to for a free response, and basically the numbers test we would need for a multiple choice question. Next problem, we have a region bounded by these two. Space of a solid, so use an isosceles right triangle. Yeah, okay. So we don't need to fully solve this just because the numbers aren't going to work out nice. It's going to be some really nasty antiderivatives and plugging in all this stuff. So we just want to create the integral expression. So let's just look at what we have. We have 2x squared, which is a parabola. We have 4x, which is a line. And we get this area in here. All right, so the first thing we need to figure out is when does this area start and stop? What starts and stops when these things are equal, so 2x squared equals 4x. I'll solve this by subtracting 4x to the other side, and then factoring out 2x. All right, so this part gives me x equals 0. This part gives me x equals 2. So now I know my integral goes from 0 to 2. Isosceles right triangles. What is the area of an isosceles right triangle? These two sides are the same. The area of any triangle is 1/2 base times height. But since isosceles, the base and the height are the same, it's just 1/2 base squared. All right, so my area that I'm going to integrate over is 1/2. What's the base going to be? Well, to figure out the base, it's that top function minus the bottom function. So 2x squared. Nope, 2x squared is not the top, 4x is. 4x minus 2x squared, and then squared. All right, so that's my formula. The height, or the area is 1/2 base times height. Sorry, base squared. But the base is this top function minus the bottom function. So we're finding the area between two curves. We have to do that subtraction to figure out the base. Again, this wouldn't be impossible to figure out. You have to like FOIL this out and stuff. It's not possible, but I don't need you to spend all that time doing it. Just creating this is good enough. You already did all the antiderivatives and stuff up here. All right, that's our final skill. Again, just think about you're integrating from the start to the finish. That's the same as we did areas between curves. And the thing you're integrating is the area of a single cross section. So here we had a square, so we just take the height and square it. Here we have an isosceles right triangle, which is 1/2 base squared. So that's exactly the formula we're using inside of our integral. All right, so that's our final skill. So now you know, or at least you've seen everything that you need for the Unit 7 test.